Okay, algebra students, here we go. So today we're working on multiplying numbers with radicals in them and how we do that. If you look at the group practice, the first thing you see is something like this. And I see right away, this looks familiar. This is my distributive property. I just have to multiply this by this and this by this. I do it like I've always done. Okay, so our basic rules are not going to change. So I'm going to do this. I'm going to say it's really square root of 2 times square root of 6, that first rainbow, plus square root of 2 times 5. Now 5 doesn't have a radical in it, so we'll just leave it like that. So let's do this. So when I'm multiplying two of these together, I multiply the numbers underneath. So that's rule number 1. When you're multiplying two of these together, you just multiply the numbers underneath. 6 times 2 is 12, square root of 12. Plus these, it's just 5 square root of 2. 5 times square root of 2. Can't do anything. Leave it like that. Then I go, okay, it seems like I'm almost done. But then it hits me. I can simplify this one. Remember, we're going to go back to our beautiful perfect squares, right? So I'm going to leave off 1 this time. I'm going to go 4, 9, 16, 25, 36, 49, 64, 81, 100. So I have that list there. I'll keep it there for the rest of this problem. Well, what numbers are smaller than 12? Only 9 and 4. So 12 divided by 9, 12 divided by 9, decimal. 12 divided by 4 is 3. So I can think about this. 12 is really square root of 4 times the square root of 3. Plus 5, square root of 2. Keep this here. Now, square root of 4 is just 2. Square root of 3, I can't do anything. It's lower than 4. I have to leave that. It's smaller than 4. I can't put anything in there. Leave it be. Plus 5, square root of 2. Now, the next question you may ask me is, well, why don't I just add 2 and 5? And I'm going to say you can't do it because they have different radicals. This has a square root of 3, and this is square root of 2 over here. So it looks like one's an x, one's a y, right? They're not like terms. They're not like radicals. That's all the work I need to do. That is my answer. Next one. This one's a funny one. This one, let's see how this one works. So I'm going to move B all the way down here. Okay, so B says this. Square root of 11 minus 2 squared. So that means I'm really taking the same number. If you remember this means, it means I'm taking the same number, even though our number's kind of funny looking like this, and I'm doing that. Now, I could do the distributive property here. I could do something else though. This would work as a foil problem or a box method. That's a 1, 2 by 1, 2. Using that old box method we used so many months ago. So I'll have a square root of 11 and negative 2. Square root of 11 and negative 2. Well, square root of 11 times square root of 11, if you put it in the calculator, one of the more interesting things happens. So if I go square root of 11, let's see what happens. I think you remember this I'm hoping you remember this from yesterday. Multiply it times the square root of 11. Watch what happens here. It's just 11. Whenever you do this, you multiply the square root of something by itself, by the same number, you just get 11. So this box number 1 is 11. This here is negative 2 square root of 11. This box here is negative 2 times the square root of 11. This box here, negative 2 times negative 2 is positive 4. So let's pull out all the numbers. I have 11. I have negative 2 square root of 11. I have negative 2 square root of 11. And then I have 4. Combine like terms. Well, I have like terms. I have my whole numbers, and I have my 2 radicals. 11 plus 4, that is just 15. Negative 2 plus negative 2, combining like radicals, gives me negative 4 square root of 11. Can I do anything else? No. That, my friends, is our final answer. Square root of 11 cannot be reduced. You can't simplify that anywhere. You can't combine these because they're not like radicals. This is just regular 15, and this is 4 square root of 11. So I stopped there. Now I got this one. This one is a big mess. It looks really bad. I get upset when I see it. That's okay. We'll figure it out. I'm going to do this. Box method, once again. Because it's 1, 2 times 1, 2. So 1, 2 times 1, 2. If you remember your box method. You can use the distributive property. If you're more of a distributive property person, use it. I just love the box method. So I put these two in these top boxes. I put these two in these boxes. Gotta keep these numbers together. Now, let's go through all this stuff. 4, well, there's nothing in front of here, so I say this 4 times 1, and then 6 times 3 in the radical. 6 times 3 is 9. Well, that's going to make it easy for us later on. Here, 4 times negative 2. 4 times negative 2 is negative 8. Now I'm looking at, again, there's another 3. Huh. Oh my God, I messed up here. I messed up. Cross it out. Start over. Do you see what I made the mistake at? Can you find it? Can you find it before me? I mean, I already know where the mistake is. Can you find it? What did I do? What did I do? What did I do? Think about it as I'm rewriting this whole stupid problem because I made a mistake. What did I do? I said square root of 3 times 6 is 9. It's not. It's 18. So this is really 4. 6 times 3 is 18. Here I'm going to multiply these together. 4 and negative 2 is negative 8. Negative square root of 3 times square root of 3, square root of 9. 3 square root of 6 times square root of 6 is 3. I do the numbers in front. Square root of 6 times square root of 6 is square root of 36. You're starting to see a bunch of nice numbers here that I know we can work with. Here, I am doing 3 square root of 6 times negative 2 square root of 3. 3 times negative 2 is negative 6. 6 times 3 inside is 18. So let's pull out all these numbers and see what they look like. Okay, let's do it in blue. So I got 4 square root of 18. I have negative 8 square root of 9. I have positive 3 square root of 36. And I have negative 6, oh boy, negative 6 square root of 18. Well, there's a couple things I can do right off the bat. I could start simplifying some of these here. If you notice right away, 2 numbers stand out at me. They're like screaming at me. They're saying, Flans, look at us, look at us. And those numbers are 9 and 36, because I know 9 and 36 are 2 of my perfect squares. So these become much easier right away. So let's work with those. So square root of 9, Try to make myself another room here. So it's 4 square root of 18 minus. Square root of 9 is 3. So 8 times 3 is 24. Now square root of 36 is 6. 3 times 6 is 18. Next one. Now I put in 6 minus 6 square root of 18. Minus 24 plus 18, easy number. We could do that in the calculator, and we get the number negative 6. So now I have 4 square root of 18 and minus 6 square root of 18. Now, next thing I realize, I have a set of like radicals. This is square root of 18, square root of 18, or radical 18. I can add these up. You could, again, one more step. Let's try it. The next step is in green. So I still have the 4 minus 6. 4 minus 6, combining like terms, is negative 2. Negative 2 square root of 18. And I still have this other negative 6, so I put it right there. And I'm like, oh my God, I'm almost done with this terrible problem. But I'm not. Because I look at 18. I say, I bet you that can be simplified. Well, what numbers are in the perfect square list here are smaller than 18? Well, there's only 3, so I don't have to do a ton of work. I look at 16, 9, and 4. Okay, so let's do 18. I'm going to do this on. I'm going to do 18 divided by 16. Decimal. No good. 18 divided by 9. There we go. 9 and 2. So negative 2 square root of 18 is really negative 2 times the square root of 9 times the square root of 2. Minus 6, of course. I'm sorry. I move this up. Now, next one, do a different color. Now, square root of 9 is really 3. Minus 6. Negative 2 times 3, negative 6, square root of 2. Now, square root of 2 can't do anything with. We got to leave it as is, minus 6. So that entire mess that we just did comes out to that. Negative 6, square root of 2, minus 6. Enjoy it. Enjoy it. It was my pleasure.